Hello, today we are going to talk about Poisson distribution. The goals of this tutorial will be to analyze Poisson distributed data, and we will plot the density function. Then we will calculate the different intervals probabilities. As a prerequisite for this tutorial, you will have to download the Excel file, and I give you the link in description. See you after the jingle. So we are now in the tab Introduction. This tab is made to give you an overview of the tool, how it's made and how to use it. So now let's go in the Data tab, where we are going to input our data. We are going to put them right here. And now let me show you our data we are going to use for this example. So I ask my ERP to make an extraction on my last 800 manufacturing order. So I ask my ERP to make an extraction and to input 0 if the last manufacturing order was on time, and 1 if the manufacturing order was not on time. Okay, so I'm just going to copy all this data, and I'm going to input them in my tool right here. So I paste each value, and then I go in the Poisson distribution. And now I select the data I want to analyze. So I select the late manufacturing order, and I put my lower specification limit, which is 10. I'm going to show you why. And then I'm going to input 100 as the upper specification limit. Then I calculate the workbook, and the tool gives me the percentage which is not inside the limit and the percentage between the limit. So I know I have 65% of luck that I will get between 10 and 100 order in late on the next 800 deliveries. And I have 34% of luck that I will get between 0 late manufacturing order and 10 manufacturing order in late on the next 800 manufacturing order. Okay. Now we have the calculation element, which gives us more information about our data. What is really interesting is P, which is 0.02, and the lambda value, which is 12. So after we have the graphic element, and that's going to help us to plot the graphs. So we have the rank, and we have the Poisson distribution, and we have the cumulated Poisson distribution. So we know on the next 800 manufacturing order to be delivered, we are going to get 11% of luck that 11 manufacturing order will be late. And same thing for the rank 3. So I have 0.18% of luck that on my next 800 manufacturing order, I will get 3 manufacturing order in late. Okay. So now we are going to see the graphs. So right here we can see the distribution between the manufacturing order which are on time and in late. Then after we have the probability plot. So as we can see, there is a really few % of luck to get 0 manufacturing order in late, and there is very few luck to get 40 manufacturing order in late. But as we see, to get 11 manufacturing order in late is a very high percentage. It's the most probable probabilities. And here we can find again the lower specification limit and the upper specification limit. And after we have the same thing, but with the probability density function, and again we can see the limits. So now we are close to the conclusion. So this tool can be useful to calculate the late trains percentage or to forecast the cashier workload. So there is many applications to the Poisson distribution, and it helps us to calculate the probabilities of rare event. And as we saw during this video tutorial, it's really easy to make it with this tool, because you just have to copy paste your different data right here. So as a conclusion, I'm giving you different links in description. You have the link to download the Excel file to do the analysis. You have the link to my website and my LinkedIn. You can subscribe to the YouTube channel and like the video. Also, if you want a new Six Sigma tool presentation, do not hesitate to post a comment. Bye.